When using Newton's law of cooling to determine the time of death, the formula to do so is shown here. That is, T is equal to the room temperature plus the object temperature minus the room temperature again multiplied by e to the power of negative kT, k being the decay coefficient and t being the time elapsed. When we plug in the numbers given into the formula, we get 75 is equal to 70 plus 80 minus 70 multiplied by e to the power of negative kT. The first step we're going to do is subtract 70 from both sides to start evening the formula out. That is going to give us 5 is equal to 10e to the power of negative k times 60 being the time elapsed. From there we're going to divide by 10, which is going to isolate the e. That is going to give us 1/2 is equal to e to the power of negative k times 60. From here, we're going to convert it to natural log, in which the natural log of e is 1, so that will cancel out, giving us the natural log of 1/2 is equal to negative k times 60. The final step is to take the natural log of 1/2 and divide it by 60, that is on the other side, to cancel it out, isolating the k. K equals out to 0.0116, which is the decay coefficient, which is the rate at which the body is losing its temperature. We're going to use the same law of cooling formula with a different set of numbers. The first number change is going to be the 80 degrees Fahrenheit, which is the time that's closest to the actual time of death because it's at 6 o'clock as opposed to the other 7 o'clock. The other number we're inputting is 98.6, which is the average body temperature, in which we're trying to find out how much time it took to get back to that temperature. The first step we're going to do here is subtract 70. Subtracting 70 will start to even it out on both sides because we want to isolate the t, being the time elapsed. That will give us 10 is equal to 28.6 e to the power of negative 0.0116 times t. The next step is to divide by 28.6 as well as convert to natural log. That's going to give us the natural log of 10 divided by 28.6 is equal to the natural log of e to the power of negative 0.0116 multiplied by the time elapsed. The natural log of e is going to cancel out, giving us the natural log of 10 divided by 28.6 is equal to negative 0.0116 times t. The last step is going to be to divide the natural log of 10 divided by 28.6 by negative 0.0116, which will isolate the t, in which the approximate time elapsed is 90.6 minutes, or an hour and a half. The approximate time elapsed is 90.6 minutes. The approximated time of death is 4:29:24 p.m. when you met your demise.